通常在演讲论坛的这个后半段会有一些重量级的神秘的演讲嘉宾出现，所以呢，也请大家再坚持一下，不要离开，因为错过你可能会有遗憾呢。那因为今天呢，我们非常荣幸的邀请到了 Michael 吴博士，那他今天也是专程从美国旧金山赶来参加我们本次论点活动的。因为接下来的演讲呢是全英文的，所以如果有需要同传耳机的来宾朋友，可以到门外去领取。Michael 呢，目前是 Lithium 科技公司的首席科学家，他的研究也跨越诸多的领域，那包括客户体验、CRM、游戏化、数字化转型、人工智能等等。那么他的研究呢，也获得了包括美国 CRM 杂志影响力领导者的认可。那稍微普及一下哈，因为这个 Facebook 的创始人扎克伯格也是在同期领到了这个奖项，所以呢，接下来呢，就让我们把时间留给 Michael， 有请 Michael 为我们带来关于人工智能驱动数字化转型的主题演讲。有请 Michael。Welcome to the stage.
Thank you. It's really a pleasure to be here to speaking to this very distinguished audience. And so basically, I have divided this talk into two parts. Basically, the first part will be about AI and what it really is. And the second part, it will be 3 areas of focus that will help you digitally transform your company. So let me begin. So the concept of AI is actually not new. But actually, hold on. Let me just give it one note here. As you see, this presentation is actually in English and also in Chinese. Okay, the Chinese part is actually all done with Baidu's translation. Okay, so I did that actually yesterday, and so you can be the judge of how good that is. Okay, so but to understand like what makes these this translation so good, we have to understand better how AI actually works. So this is the first part of my talk. Okay, so let me go on. So first, the concept of AI is actually not new. And this is actually heavily dramatized and fantasized by the entertainment industry. Basically, you know, if you haven't seen this movie, you probably have seen this guy, okay? And we all know AI as basically it's this super smart, you know, human being, right? They're not really human. They're humanoids, right? They work at the speed of light. They can remember every single detail. And what's better is that they work 24/7 and they are always learning and they constantly get smarter, okay? But what's even better is that like they actually never get tired and they never complain, okay? So if you are a company, wouldn't you want to have these people as your worker, as your employees? You probably would, right? So, but let me tell you, this understanding of AI is actually really, really shallow. And it actually would not help business understand and leverage the power of AI. So, instead, it actually creates a fear. It creates a fear that when is AI going to replace all of us? Okay? So if you have this fear, basically the business, you know, the adoption of AI will basically slow down, right? Because one day we may be all out of job. Okay? So, in order to understand how business can leverage AI more effectively, let's take a few steps back and understand what business have been doing for the past, I would say, 30 to 50 years. Okay? And that's basically business analytics or business intelligence. So I'm going to give you a very quick history and evolution of business analytics. And I'm going to use the stock trading data as an example. Okay? So first, when you actually get lots of data, the first thing you do is you compute some summary. Right? So you can understand what the data is doing, what the trajectory might be. So you compute these local trends, global trends, resistance point, these different indicators, right? All of this is what I call descriptive analytics. You're just describing data that already exists, right? So, but after you do this for a while, you may say, okay, now I have a pretty good understanding of what the data is. So I'm going to make a model, okay? So once you make a model, the nice thing of having a model is that now you can extrapolate the model to regions where you have no data yet, right? So basically, you could predict right, what the future trajectory might be, okay? When you do this, you basically move into predictive analytics. And of course, when you're doing your predictive analytics, you don't just forget about your descriptive, you continue to do them, right? But one good thing, one really nice property of having an eye into the future is that now you can tell the user what to do. right? Basically, you can tell them, this may be a good time to buy, right? Now, when you do this, you basically move into another area. That's what we call prescriptive analytics, right? You're prescribing something for people you're telling them what to do in order to achieve something, right? So again, you don't forget about your predictive and descriptive analytic. You continue to do those, but your prescriptive analytics system may be really smart, and they may tell you to, for example, like buy right there, sell 50%, and if you continue to go up, sell more, okay? So this is basically a very quick evolution of business intelligence, business analytics. It goes from descriptive, describing, to predictive, to prescriptive, right? But so everybody understand what descriptive analytics is. It's simple, right? Just summarizing data. But a lot of people have a lot of misunderstanding of what predictive analytics is all about. Predictive analytics is not just about forecasting the future, okay? Let me say that again. It's not just about forecasting the future. Forecasting the future is just one application of it, right? Really, you know, when you actually look at forecasting, it basically is what we call a temporal prediction problem. Right? You are trying to predict in time what's going to happen in the future. But what you're doing there is that you're trying to take historical data, you build a model, this is actually the present time, right? And you build a model, and then you put these historical data in there, you get actually a future prediction, right? So that's what a trend line is. The simplest predictive analytic is a trend line, okay? Now, the important thing to realize is that the general version of predictive analytics is actually not limited to time domain, okay? You can actually estimate things. It's actually about using data that you have to estimate data that you don't have. So that's, in that case, you can actually see that, you know, predictive analytics, the forecasting future is just one specific application, right? The data that you have are historical data. The future that you cannot have, you don't have, but you want to have, is the future data, right? In fact, you can never have future data, right? So you can only estimate it. Okay, so let me just give you a couple more examples, right? So I work a lot with social media data. So one example is, for example, social media scoring of influencers, right? So here in China, a lot of people use WeChat. How do you know who is influential on WeChat, right? So it's actually a very useful application. So basically, the data that you have there is basically social media interactivity. Who replied to who reshare whose content, right? And then you put that into a algorithm, we call it the influence algorithm, and then you have a score. It tells you who is more influential than other people, right? So, and a company that does that is Cloud, right? And we basically, they're part of us now. And another example that a lot of you might have heard of is sentiment analysis, right? Basically here, the data that you have is basically text, any text data, right? It could be blogs, news article, could be message that you send on WeChat. All of these text data, right, are data that you have, you can get. And then what you do is that you want to put them into this sentiment classifier. This is the model that you built, and then you get out positive or negative sentiment, right? So this is data that you want to have, but you don't have, right? So you will know how people feel about a particular product or particular company or particular person or so on and so forth, right? So this is basically, I would say, a much more useful way of looking at predictive analytics. It's about estimating data that you don't have. It's not about forecasting the future. That's just one use case, okay? So let me talk about prescriptive analytics. Prescriptive analytics is, I gave you a really simple example of predictive analytics, and that's a trend line, right? The simplest prescriptive analytic is a GPS navigator, right? Basically, why is it a prescriptive analytic? You can tell you where you want to go, and you will prescribe your route on how to get there, right? That's a very, very simple prescriptive analytic. But keep in mind, there's actually an infinite number of ways to get from A to B, right? You can actually go this route. You can actually even go around and come back on this route, right? Why do you think it prescribed this particular route? The reason it prescribed this route is because this route probably optimized something, right? The early days, GPS probably optimized for the shortest distance. Today, GPS is actually a lot smaller, so they optimize for the shortest time, right? Maybe they take into consideration of traffic, take into consideration of the mode of transportation. Do you want less walking? Maybe it's raining, you don't want to walk, right? So it's optimizing some objective function. There's infinite number of ways to get from A to B, but it's optimizing for some objective function, for example, the shortest time, and it prescribes this route, okay? So prescriptive analytic, every time they prescribe you something to do, you have to ask yourself, what are they optimizing? That's the best way to understand prescriptive analytic, okay? So as I said before, right, the simplest prescriptive analytic is a GPS. Compare that to a trend line, which is a very simple predictive analytics, right? But as I said before, the general predictive analytic is not limited to time domain, right? You see a couple of examples of that already. Likewise, the general prescriptive analytic is not limited to prescription of a route in a geospatial domain either, right? For example, you could prescribe business strategy. For example, I want to increase my sales by 20%, right? That's where I want to go, right? And your prescriptive analytics system may actually tell you, okay, now you have to first hire really smart engineers, build a product, and then hire marketers to market about it, and then hire salespeople to sell. It may tell you what to do, a sequence of action in order to get to where you want to go, right? That's prescriptive analytics in the business domain, right? Not in the geospatial domain, okay? So now you understand the evolution from essentially from descriptive to prescriptive. So you say, what's next, right? What's next, right? So what's next is that to answer this question, we have to understand what role do business intelligence actually play in the history of business. Basically, business intelligence is what we call a passive decision support tool, right? It's passive because it doesn't matter what the data tells you, right? Whether this is better route or which one is better stock to trade or better time to sell, right? At the end, humans make the decision, right? The GPS can tell you turn left, turn right here, but you say I don't want to go this way. I could go straight, right? Human make the decision at the end. Human always have the power to make decision, right? And that's actually for a very good reason. The reason is because traditional analytics actually have very limited accuracy, okay? And if you actually look at his history, let's try to understand why that's the case. Okay, we have data. The data have grown exponentially over the past like 50 years, right? And we also have essentially models that crunch this data, right? It goes from really simple models to something really, really complex, like deep network and so on and so forth, right? The more complex the data the more complex the model is, requires more data in order to fit the model, right? So basically, the accuracy of this analytics basically requires this data to be crunched by this model and then produce a result. The accuracy of this result basically depends on three things, right? It depends on, of course, the data, right? If what goes in is garbage, what comes out will be garbage, right? And it also depends on your model, how good is your model, right? Does your model describe the reality? And finally, it's also limited by essentially your compute power, right? The CPU. This is a practical constraint, right? It's no good if you actually get the result. That's really good, but it takes you 10 years to get it. Useless, right? So early in the days of, like since 1950, when we're still using vacuum computing, right? We already have a pretty good understanding of the theoretical, from the theoretical aspect of neural network, okay? Those are not deep network. Those are what we call shallow network. Essentially, they're 2 to 3 layers deep, okay? But the important thing to know is that like early on, we are actually limited by data. Even though if we have the data, those data are not digitized, so it actually cannot be used, right? And but very early on, we are actually limited by computing power, right? So I'm going to go through this very quickly. The important thing to recognize is that over the past like next 20 years or so, right? Basically, our theoretical understanding of model increases, but it more or less increase in a linear fashion. But the amount of data that we have access and the amount of computing power that we have access actually increased exponentially, right? So by the 1980s, we almost have enough CPU power to use the most advanced model at that time, okay? So now, we can't use it for all the data yet because that's still a practical constraint, right? Because the data actually will actually increase the computing time, right? By the 1990s, right, we can almost use the most advanced model, right? And then in 2000, we had distributed computing, right? So that basically just means that we pretty much have infinite compute power, right? It turns this compute power into an economic constraint. Whoever can buy the most computer will have more computing power, right? Because you can just distribute them across as many computers as you want, right? But what happened in 2010? In 2010, basically, now we had GPUs. That further increases your computing power. But what it does is we also have big data, right? Now, that basically lifts the constraint on data. We have no more constraint in data. And basically, we have no more constraint in compute power. So what does that allow you, data scientists like me, do? Basically, we can use as sophisticated as a model as we want. right? Basically, these models are deep network, recurrent neural network, right? LSTM, names that you probably have never heard of, okay? These are very, very sophisticated networks that actually mimic how our brain works, okay? So now, as a result, the results of those analytics are much, much more accurate today. They're very accurate. So the question for you guys is that, well, what happens if the result of these analytics is always agree with the human expert, right? What happens if I always agree with human? Do we still need to have a final say, the final decision? Do we have to say, yes, 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 you're right, AI, you're perfectly right. Every time you say yes, 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 continue yes. Right? Do you need to do that? Probably not, right? In fact, today, machines can actually leverage data from multiple experts, right? So the result of those analytics may be actually better than any single one person. They may not agree with it, but actually it's better statistically, right? So in that case, do we still need to have a final decision? Probably not, right? Probably not. We could just automate it, right? Because it's already telling you what to do, right? You just click a button and say, I agree, and then you just does it, right? So this is actually the essence of AI. This is what the essence of AI. So I think the screen is a little bit out of sync there, but someone maybe could fix that. So this is the essence of AI, right? Basically, the artificial intelligence is the automation of these decisions plus the proper execution of all the subsequent actions. That is what AI is all about, right? And just to illustrate this a little bit, right? Basically, from going from data to decision to action, that's typically the job of a human being, right? But now you can just automate it, right? You can go from decision to action as if just a part of the process, okay? Now, for example, this is actually here today. For example, we have algorithmic trading. Algorithmic trading, rather than telling you what to buy, or what to sell, when to sell, it just trade for you. It just make the transaction for you, right? In the US, there is robo-advisor. They just trade for you, okay? There's also automated loan origination. Once you meet the condition, and once you actually satisfy the requirement, they will just offer you the loan, right? So another example, let's go back to the geospatial domain. Let's go back to the geospatial domain of a GPS, right? Rather than telling you when to turn left and when to turn right, just take me there, right? Just take me there. There's no need to tell me, you know how to get there, right? You just have to take me there, right? So this is already here today, right? It's not widespread, but it's here, right? So let's try to understand what makes AI so smart and so intelligent. What makes them so smart, right? You often heard of probably deep learning, right? Deep learning is a hot topic today in this research area, right? It's probably because deep learning, if you ask, what is deep learning anyway? People say, oh, it's just one kind of machine learning. And then, so what is machine learning anyway? And then they would say, oh, it's probably one kind of AI. This is actually wrong. It's actually not true. Machine learning is used in AI, but it's not a kind of AI, okay? So this picture is actually incorrect. Let's see how we can understand a little bit better, right? Even though it's not completely incorrect, it's at least not useful. It's not useful in telling you what to do, right? So let's try to understand it in a more useful way, a more practical way, right? So first, you start with big data, right? You already have lots of data, and then you use those data to build a model. Typically, it is a data scientist like me, right, who build a model, right, using machine learning. If you attended my session in the morning, I talk about machine learning and deep learning, right? So that's the job of data scientists, okay? So some of these models basically are prescriptive analytics model, right? And after they prescribe you something, you have a decision to make. You can either follow it or not, right? And after you make a decision, there's some action that you need to carry out. After you carry out the action, there's some outcome, right? The outcome need to be fed back into your prescriptive analytics system in order for you to do this better the next time, right? So, and the interesting thing is that, like I said before, right? If your model is good enough, right? Basically, typically, decision is made by human. Human make the decision, right? What about action? Who do you think decide what to do? Okay? Basically, it is between human and robot, right? In the digital space, you could basically use a robot to do that, right? In the physical space, you may need robotic, you may need a self-driving car, right? So this is an area that's actually heavily invested as well, right? And what about the feedback? Who collects the feedback? Today, basically, traditionally, humans collect the feedback by survey, right? But this is very, very slow. It's not very effective, right? So in order for this to be effective, this basically needs to be this feedback needs to be in real time, right? So basically, we can't do the survey anymore, right? We have this feedback had to be tracked automatically, all right? And so as I said before, right, now, if you have this model, right, this model is good enough, basically you can automate this decision as well. There's no need for human, because the human is going to agree with with what they prescribe every single time, right? So there's no need to have human there. What about action? As I said earlier, right, you basically need to invest in robotic and self-driving car and so on and so forth, right? But in the digital world, this can already happen, okay? So pretty much we want to automate everything in this loop. So when you have this automated kind of prescriptive analytics loop, basically, this is what traditional prescriptive analytics offer, right? But the nice thing about the fact that everything is being tracked automatically is that now you can feed this data back to your big data store, right? What does that allow us to do? To understand that, take a look at this picture. What's wrong with this picture right now? What's wrong with this picture is that this model never improves, right? The model never gets better, right? The human makes a model, and then until he's happy and again to make a new model, the model never improves, right? So now if everything is tracked automatically, you can feed all this data back to the big data store, and those data can become new training data for you through machine learning to improve your model, so that the next prescription from prescriptive analytics will be better than the one before, right? So every time it gets smarter and prescribe better action for you to take, right? When you do this, basically, this model becomes semi-automated, right? Humans still need to watch it, right? You don't want the complete automation because the machine can actually learn something wrong, right? And prescribe something that may not, for example, may not be legal, may not follow the legal compliance and so on and so forth, right? So humans still need to watch it. But once you have this model, right? This model will be a very good model for what's going on here to here, from decision to outcome, okay? So this is what we call the learning loop. The learning loop is what makes AI smart, right? They don't have to be smart at the beginning. But the important thing is that it gets smarter every single time, every single day, right? And because of this feedback system. That's how it becomes smarter and smarter, okay? So how can you take advantage of this AI trend? How can you take advantage of this AI trend? This AI trend, well, this is actually a GPS that we use in the US very frequently. It's called Waze, okay? So unlike traditional GPS, it doesn't optimize for distance. It optimizes for time, okay? So as a result, sometimes it actually tells you to go on this blind alley that you never go before, okay? It will tell you okay, you should turn into this alley. And then, so people often have this weird experience. Why does it tell me to go to this blind alley? I never took this route, right? It's really weird. But at the end of the day, it actually leads to the destination earlier, faster, okay? So that's really important, right? So this is actually a situation that I encountered a couple months ago when I was speaking in Istanbul, right? I need to get across the Bosphorus Strait, okay? So if you actually look at it, getting from the green to red, it's actually very close, right? But if you actually look at the prescription that asked me to go, right? And you actually look at the distance, it's supposed to get me closer to the red button, right? The red icon. That's what it's supposed to do. But if you actually look at the actual distance that you plotted, it actually looks like this, right? It actually spend most of the time getting away from the destination, and then the last third of the time it gets closer to the destination that you want, right? So is this okay? Is this okay for you? I mean, in the geospatial domain, probably, because we understand that we cannot drive through water or drive through the river, the strait, right? What if this is in the financial domain? What if this was an automated kind of trading platform, right? Say I wanted to invest $1 million and get 400% return in 6 years. What if, so basically this is the picture, right? I sink in $1 million, I want to get back 3 million in 6 years, okay? I want to get to positive 3 million in 6 years, right? So what if the prescription was this? What if you have to lose 2 more million before you get back your money, right? Are you okay with that? Do you trust the AI when it prescribe this? So you could impose some kind of constraint, right? You could say, okay, maybe you cannot lose more than 500,000, right? Then maybe it will prescribe you something like this, right? What if you don't make any money for the first 5.5 years until the very last 6 months you make all the money back, right? Are you okay with this? What if this was the only way, right? So you have to learn to trust AI. If you don't trust AI, basically you will end up basically like the GPS. Right? If I don't trust AI, the GPS may tell me to go that roundabout route to get across the strait. If I don't, basically I may end up getting to my destination much, much later, right? So if you don't trust AI, you may lose all the money, right? So be careful, right? So ultimately, in the geospatial domain, we can see the landscape, so we know where we can go, where we cannot go, right? But in these, I would say, non-geospatial domain, right, it's actually very, very hard to visualize the landscape, right? Even if you could look at it, you may not see what's the actually best way to get there, okay? So we just have to learn to trust AI and learn to work with them, right? So in the interest of time, I will not go into this very detail, right? Basically, I talked about this before earlier, right? Now, how does all this relate to digital transformation? This is the problem of garbage in, garbage out, right? So you have data, and it goes into crunched by your model, and then you that result you basically automate it and automate those decisions, right? So that's basically AI, right? So if you have garbage going in, what comes out is going to be garbage. So what that means is that your AI can only be as good as your training data. So the next question for you is, how do you get good operation data about your business, right? That means you have to start digitizing your business, right? Turn all of your business process and communication and operation into digital process. And so that can be used by AI, right? What that means is that you have to start your digital transformation. Okay? Digital transformation is at a high level is really simple. It's the adoption of digital technology to transform how your business operates, right? And so technology is only the first step. But you have to eventually change your people, your process, as well as your company culture as well. And that actually is a long journey, okay? And unfortunately, I am out of time. I actually don't have time to go through all this analysis with you. But this is actually why you need digital transformation in order to actually enjoy the power of AI, okay? So digital transformation is a long journey, right? It starts out as a silo project within a department, but you have to eventually essentially transform the entire company, its culture, the process as well. Okay, so this is the picture that I want you to have in your mind. Basically, digital. It all starts with digital economy, right? How can business leverage AI? It starts with digital economy, because only then, basically you will have digital transformation, right? So this is very difficult, but I will talk. I don't have time to go into this in detail. Right? Only then will you be able to collect good enough business operation data, and only then will your results from your analytic will be good enough, right? And only then can human trust your AI, right? And only then human can trust AI, and only then can actually your business will leverage the power of AI. Okay? So stop asking yourself, what can AI do for you? AI can pretty much do anything that we can do, pretty much anything, as long as you can digitize it. So instead of thinking what AI can do for you, think about what can you digitize, right? Because that's going to help you in the long run and what AI can do for you. Because anything that you could digitize, you could use it to train the AI to help you do, okay? So with that, I'm out of time. Thank you for your attention. So we could connect and speak more. Thank you again.
Thank you so much. Welcome. Well, very impressive. Thank you so much, Michael. Actually, I'm not sure, would you mind to speak Chinese maybe someday in the future, but leverage AI next time? OK， 非常感谢 Michael 的精彩分享哈。我们今天上午 Michael 的这个分论坛也是座无虚席，甚至连站票也都是一票难求了。我们今天这个机会也是非常的难得，也感谢他的分享。那今天。